Hello, my name is Orestes Ratimus, and I'm doing my lab presentation for the course of Physics 2212, Magnetic Field of a Bar Magnet. So, in this lab, we will measure the distance dependence of the magnetic field due to a small bar magnet. We'll compare our measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart laws. So here we have the different forms of Biot-Savart law, with distance dependency being n and the magnetic dipole moment being mo over 4 pi. So in order to measure the magnetic field, we used the magnetometer app called Teslameter, with having the x, the y, and z component over here. So first we compensated for the magnetic north by setting the bx equal to 0, and then we were trying to move our phone in both directions to find the magnetometer tip. So this is the final result of finding the magnetometer being here with the x. And then for specific bx measurements, 20, 70, 120, 170, and 22, we found the distance of the magnet from the magnetometer sensor. And we got these results in yellow and the average on the right. Before moving on, there are some few observations. It is true that when the magnetometer is far away from the magnet, it measures a zero magnetic field in the x direction. It's false, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field decreases. It's also true that the position of the magnetometer has no effect on the measured x component of the magnetic field, and it's also true that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So moving on with the experiment, we measured the off-axis magnetic field when B net equals 100 macro Tesla, and we have here the results. This is the deep distance, and we'll later see how we measured the B earth and B corrected. And here's the example. As we see here, I wanted to mention how I found the rest of the by corrected. So basically it's that we have the vectors. Imagine that this spot is here and this spot is right here. So we have the B measured equaling the difference of B magnet minus By earth. And so the B magnet is By plus By earth. But be careful, because the size of the field will indicate whether to add or subtract, since we're handling vectors. And so in my case, I did the difference. This is the final picture of my results. And here I calculated the mag with using the slope and the y-intercept. So using here the slope for the k times r, and here we will use the ln k equals the y-intercept, and we have the final result right here. And so we also have the glow script computations, physical studies, creating the magnet at the origin, editing to create a fraction for the magnetic field, visualizing the magnetic field, scaling the arrows, and creating 2 arrows to represent the magnetic field on axis. We also have 4 arrows for the magnetic field perpendicular to the axis. And then finally visualizing the magnetic field. Here is the visualization. The orange vector is the magnetic field on axis, the blue vector is the magnetic field perpendicular on the axis, and the silver object is the dipole, which is basically the bar magnet, with the final result being over here. So the compared values is that the measured 45-degree value of B net, which is basically from the EXL, is 0.000170141 Tesla, whereas the computed in the glow script, the B net is 00006236147524 Tesla. So basically we have a difference, and that's understandable since there are experimental errors when we measured the 44-degree value of B net. And we make mistakes, and we have to also what if statements. So what if we haven't oriented our experiment to compensate for magnetic north, and had instead laid out a relativistic to some intermediate angle with respect to Earth's magnetic field, well, the result would be definitely very far from the truth, since both y and y component, x and y component will be really off and will not represent the truth. And if we had to stick two identical magnets together end to end, the experience would have a different magnitude of the magnetic field, definitely larger, but the direction would be the same. And basically, the magnets would be treated as one with double magnitude but same direction. Thank you very much for your attention.